Good morning, everybody. Good morning. Just going to wait for a few more people to get in from the lobby. Good morning. Amazing. Well, everybody, welcome to another spring showcase. Today we're partnering with Northumbrian Water to find out how they have worked alongside organics to recover up to 4,400 tonnes of high-strength ammonia from their treatment processes. My name is Chloe Tooth and I am the Knowledge and Communications Manager here at Spring Innovation. For those of you who might not already know, we are the Innovation Centre of Excellence for the water sector, supported by all the water companies across the UK and Ireland, as well as the supply chain and academia. We're here with the goal of enabling collaboration, removing duplication and accelerating innovation in the water sector. So we are the custodians of the Water Innovation Strategy 2050. For anyone who hasn't seen that document, we're going to pop some links in the chat to that in a second. And that lives on our website. It has 7 themes with challenges that sit under those themes that we want to be solving within the sector. We also at Spring put out calls for innovation against those themes through our Spring accelerators. But today's service offering is about knowledge sharing. So we have 2 aspects to that. The first being our knowledge library on our Spring platform, where there's a bank of over 50 case studies for you to go and learn from and utilise on innovation projects from across the sector, with over 190 more case studies currently in the pipeline. This is constantly being updated, so please do go over and register and check those out, and there'll be a link to the platform as well also. So the showcase recordings for a number of those projects and any supporting links or documentation also sit alongside those case studies, so make sure you register and go and check those out. So this is a 2-hour knowledge showcase event, and we're happy to see there are 91 people registered for today's event, with representatives from the Netherlands, Poland, and lots from Australia today in this one. So welcome to the call and thank you so much for joining us. Today you'll learn more about how Northumbrian Water have been looking into how they can assist the UK and Ireland water companies to meet their future total nitrogen contents, minimise nitrous oxide emissions and reduce power consumption during secondary treatment. This is showcase number 20 for Spring, and with over 2,700 people registered for these events, we're super happy and really proud with how these events are helping to disseminate knowledge from these innovation projects and accelerate learning across the sector. These showcases are all about being able to learn a little bit more about the project and take away those learnings and that knowledge and being able to embed those in your organisation where you can. This being said, we will be launching a poll at the end of this showcase to find out how interesting you found the information and also whether you're hoping to go away and use that afterwards. So please do submit your answers at the end of this event when that comes through. So on to today's session, I'm just going to run quickly through the agenda before I pass over to Clive. So I'm just going to introduce the speakers first, go into the importance of knowledge sharing with Clive Wells. We're going to do a little bit of the context and value behind the project, go into the organics ammonia recovery, a little bit about the lessons learned and the roadmap, and then into a short break before we go on to other relevant projects and the questions and answers session. So if you do have any questions throughout the session, please do pop those in the chat and we'll do our best to answer those at the end of today's event. Just so you know, any questions that aren't answered today will be alongside the case study when that's uploaded at the end. So please do make sure you pop any questions in the chat function. So without further ado, I'm just going to introduce your speakers. So we've got Clive Wells, Innovation Partnerships Manager at Northumbrian Water. We've got Donna Rawlinson, Capital Delivery at Northumbrian Water. We've got Matthew Peckerskill, Wastewater Innovation Coordinator at Northumbrian Water. And we've got Keith Richardson, Commercial Director at Organics Group. So it's about time to pass over to Clive Wells to talk about the importance of knowledge sharing. Thank you.
Hello, everybody. We're obviously very excited to be doing this showcase and thank everybody for coming along to hear about it. It's great to be talking about a successful project, not without its hurdles and its challenges, which you're about to hear about from Donna, Matt and Keith. So the importance of knowledge sharing, it's really crucial because Not every innovation project is going to be successful, and if it doesn't reach its goals, it hasn't necessarily been unsuccessful because you still have the knowledge. In fact, that's probably all that you have. And of course, when it comes to scaling up an initiative and disseminating across the industry and hoping for adoption by others, if we're not sharing knowledge efficiently and effectively, then you haven't of doing that. Ofwat have given two very clear signals about the importance of knowledge transfer in the most recent round of the competition, in that they introduced a new question. Just go back one slide. They introduced a new question into the competition, specifically around how knowledge is going to be shared. And they also asked us to break out the costs of dissemination across. So really crucial. Next slide, please. So Northumbrian Water, what we tend to do with all of our bids into the Water Breakthrough Challenge is actually include a work package in the bid itself to ensure that we really cover this comprehensively, both from awareness through knowledge sharing and dissemination to wider stakeholders. And there are all sorts of tasks and activities there. You can see they're actually tasks on a project plan to make sure that we cover that, and they range from speaking at conferences, launching projects at our innovation festival and using that as a dissemination mechanism, setting up a dedicated website to create a community of people who can stay in touch with the project as it progresses and as the knowledge is shared, and of course centrally through the Spring Dissemination Services and the thing that you're at today, a Spring Showcase. So we're doing all that we can to disseminate and share information about our projects, successful or otherwise. So I'm going to hand over to Donna, Matt and Keith now to tell you all about the project.
Good morning, everybody. So I'm Donna Rawlinson, part of our capital delivery team within Northumbrian Water. I've been working within the area of bioresources for the last 20 years within Northumbrian Water. And one thing, carrying on from what Chloe and Clive are saying, is we've always been really keen to share the great work we do here within Northumbrian Water. In terms of the world of bioresources, we are a highly performing company within the UK, and we're always looking to continuously improve. Now, in terms of this particular project, removing ammonia from our Howden wastewater treatment process using organics technology, this has become really important for ourselves. From the world of bioresources, we already have AAD installed on our site, and we know that there was a great opportunity with our return liquors from the AAD process and what we could do better with it. So in terms of the presentation today, I'd like to touch on what our Northumbrian Water's environmental strategy looks like, a bit more detail in terms of what the great work we've done so far already at Howden, and then also looking at where we are in the world of innovation, some of the great ideas we're up to progressing, and an opportunity for you to get involved in the future with ourselves as well. Looking specifically at the organics project, we have already recognised we've got this great prize in terms of our AAD return liquors. Actually, it's how big is that prize, and I'm going to share some facts and figures on that later throughout the presentation. A bit of detail that Keith will focus on in terms of how the organics kit actually works. An overview of what our results are saying so far, what our conclusions are, what lessons we are learning, and what we're looking to do next, because albeit as part of the Ofwat Innovation Fund, this part of the trial is now complete and it's been a complete success. The results are so interesting, we're looking to progress this further and hopefully get a plant that ends up being installed somewhere. And again, on that, I'll give you an overview on what that roadmap may or may not look like. I dare say, to put things in perspective, what does the organics part look like at the moment on the Howden site? It's a containerised unit, relatively small, taking relatively low flows. And I dare say, some context there, we started working with organics back in 2021. This project should have completed in 2022, and Keith's smiling because we've laughed all the way through. We have had issues. Initially, we had COVID. that absolutely blew our programme out of the water. We had an extensive delay there. We had issues getting the equipment delivered into the UK, so it was fabricated from Thailand. Again, worked really well together to resolve those and get the kit installed at Brownsands at Howden as quickly as possible. The kit actually only arrived here in the UK in April 2023. And through the great work of Organics, we actually got it up and running within about 2 months. And again, that was a great task of teamwork between ourselves within Northumbrian Water and Organics working together. So in terms of Northumbrian Water's environment strategy, and we've got 5 pillars on the environment strategy, and this is pivotal to it. So the circular economy is something that we're really passionate about. In terms of other activities happening in the UK, we've got Aqueous, which is a UK water research. Dear me. But I'm the programme lead for Aqueous. And again, I'll encourage you all to go and look at the Aqueous website. Circular economy and resource recovery is embedded in some of the big questions we've been looking at for that. And what we're doing within the organics plant is absolutely pivotal to that. So we're all focused on resource recovery, circular economy, and I encourage you all to go and look at our environment strategy. And I think we're going to post a link into the chat so you can all access that. So in terms of some of the great work we've been doing within Northumbrian Water so far, if I can turn the clock back to 1985, at that point in the UK, our wastewater treatment processes were quite simple. We had primary settlement, but then actually ended up exporting all of the waste solids to sea. And this continued for many years. In the mid-90s, Urban Wastewater Directive was introduced, and that resulted in Northumbrian Water taking a massive step change to obviously improve our wastewater treatment processes, but moved us towards drying. And again, when we look back to the mid-90s when this was commissioned at our site in Brownsands and Teesside, yes, it worked, but from a sustainability point of view, the amount of electricity and gas that process required and the maintenance burden of that process really wasn't workable for the long-term future. There's also a photograph of Tony Rutherford, who is the works manager here at Howden, and I think that wraps up where we got to as an industry from the mid-80s through to the mid-90s, where the impact of Urban Wastewater Treatment Directive that resulted in the River Tyne here in Newcastle having a significant improvement, and that's a photograph of Tony, who is also a fisherman, collecting the biggest salmon he'd caught in his history, known to where we are in the Tyne, and that work is continuing. In the mid-90s, so when it comes to 2005, we then started looking at our bioresources process again. We recognised at that point that drying was not sustainable, certainly wouldn't be a long-term solution for ourselves in Northumbrian Water. A lot more options were coming onto the market, and quite quickly we completed a review, and the decision was that we were going to install AAD, advanced anaerobic digestion, on our 2 sites in Northumbrian Water, Howden here in Newcastle and Brownsands in Teesside, and that gave us immediate improvements from an environmental perspective and a carbon footprint, but also from our cost base as well. Our operating costs significantly reduced overnight. By now, the momentum was really gathering some speed, and certainly within 3 years, we recognised we could do things even bigger and better. We then upgraded our AAD plants, which were operating with CHP to produce renewable electricity. We then upgraded those to result in biogas, biomethane going to grid. And again, a huge success. So by now, we've got a highly performing AAD plant. We're doing the right things, best use of the biogas. And our next improvement is actually what we can do with our side streams. So within AAD, we get some high strength ammonia liquors from our dewatering process. We see that as an opportunity, and that's really where we got to the discussions with organics. We're not stopping here. We're now looking at actually what comes next. We know that the regulations in terms of recycling to land are going to impact on ourselves within the water industry in the coming years. And we're working with companies such as Organics in terms of what can we do next in terms of advanced thermal conversion. So that's very much forward looking in terms of what could happen next within the water industry. And I'll pass over quickly to Keith, who will talk about a similar journey within organics.
Yeah, so 1985, really, the company started in the UK. Landfill gas primarily, so we're a thermal engineering business. That's generally speaking where we came from. And as the sector sort of developed, we went basically international with it. And during the 1990s, we're heavily involved in the clean development mechanism, basically CO2 reduction projects, primarily landfill gas again. In sort of early 2000, we were given the challenge by Suez in Hong Kong to treat highly ammoniated leachates. And at the time, they basically didn't have any use for their landfill gas. And we basically developed the ammonia stripping technology for particularly for Suez. Currently now, I think we have 19 facilities, 19 ammonia stripping facilities in Hong Kong on all our landfill sites there. We've basically adapted that technology and brought it into the municipal wastewater treatment sector. Sort of, during the sort of late sort of 2000s, 2005, 2010, we got involved with gasification pyrolysis. We've since adapted that technology recently to go into biochar production, and we're doing that in Southeast Asia in particular. And then the ammonia recovery, as I say, well, 2 or 3 years ago, we sat down with Northumbrian Water and came up with the idea of doing this trial. And it really has been sort of a pivotal sort of change for us. A lot of interest in it globally. Yeah, we're looking forward to going to the next step.
So I think what this slide summarises for myself is actually organics and Northumbrian have followed a very similar path in terms of that continuous improvement and how we can do things better. So Northumbrian Water, in terms of our AAD return liquors opportunity, we've got 2 AAD plants, one here in Newcastle and one in Teesside. Within the UK, when we talk about bioresources, we talk tonnes dry solids. So we look with the total tonnes dry solids we have within Northumbrian Water is 70,000 TDS per year. And from that, we are producing 165 gigawatt hours of biogas. And we've got plans to increase that to 175,000 gigawatt hours by 2035. And that is about making our processes more efficient, potentially looking at the import of commercial bioresources and other plans we have in place. As a side product, we have to deal with 96,000 tonnes of digestate, which we use as a fertiliser. And then we've got the gift of about 8 megawatts thermals of waste heat available between Bransands and Howden. And again, it's how best do we use that waste heat. So again, we're continuously looking at our process from start to finish on how we can improve. As a further byproduct from the digestate, so it's great news that the solid portion gets recycled to land. We then have to deal with 2.5 million cube of return liquors, and that currently goes back to the main treatment works. Now, the importantly is a composition of this return liquors. So it's high in suspended solids, high in COD, but it also contains about 3,000 milligrams per litre of ammonia. And this is where the real opportunity is. How can we recover and abstract that ammonia? If we're able to do that, and we are, and the exciting results will be shared with you very shortly, we've got an opportunity to recover 4,400 tonnes of high strength ammonia. And again, back to our growth plans, when we're able to grow our plans to with our more efficient processes, actually that allows us to recover even more volume of ammonia. So again, that prize is continuously growing. Almost as good as the prize of actually being able to market the ammonia, we've got the energy savings on the main treatment works. So we've estimated that we've got a 40% reduction of our aeration costs at Bransands. Now, again, admittedly, that's because we've got an existing tight ammonia consent at Bransands. But again, we're going to come on to this later. That consent is only going to get tighter. So potentially we've got the opportunity to reduce our electricity burden from between 40 to 50%. And again, that is going to be a real prize, and that runs into hundreds of thousands of pounds per year OPEX savings, up to about £500,000 OPEX savings per year. We know that with the introduction of AMP8, which is our next regulatory period, we are going to have tighter ammonia consents. Actually, we've got total nitrogen implications where we've got to take that ammonia down to as low a level as possible. Again, this is a real opportunity, actually. If we can reduce at a source, actually the burden on the rest of the plant is much reduced. And this is a key area we're going to focus on this morning. And then also the impact of carbon. So we know that throughout the treatment process, we have to deal with process emissions. In terms of technology that's available now to monitor those process emissions, that is becoming more developed. What we do know is actually if we can remove the ammonia from source, that reduces that burden of those process emissions downstream in our process. So in terms of innovation, our ambition is to be leading innovation, both within and beyond the water sector. We rely upon partnerships to deliver our innovation, and that's again as an example of how we are working with the likes of organics to do things differently. I would encourage all of you to go and look at our link for the Innovation Festival. This is an annual event we run every year. This year's event is going to be it's going to be held in Newcastle. It's for a week in the summer. And this year we're going to have a sprint specifically looking at biorefinery. So how can we look at our wastewater treatment process and take us to that next step? A sprint that we're really excited about in terms of actually how, as an industry, can we do things much bigger and much better. We've obviously had the gift of the Ofwat Innovation Fund, which again, we're continuously looking to develop our ideas further. And specifically with the organics, we're looking at actually, well, what comes next? What can we do with the organics technology to get some additional funding to really make it clear we are innovating? So in terms of going on to the main research project itself, this commenced in 2021, as I've already mentioned. Its main focus was on recovering ammonia, which again we've been successful at. It has to be cost competitive, so we know that for it to be successful, to embrace a circular economy, if we haven't got that viable market or we haven't got the reduction in OPEX, then it won't be successful. And again, we've been working with organics to exploit that as far as possible. And we also know we have that challenge of those tighter ammonia consents, and we know we need to reduce our process emissions. And we think that the organics will be a key way of how we're going to actually deliver against that. We haven't been working in isolations. Obviously, organics are our main partner, but we've also been working with Anglian Water, and we've also had interest from most other water companies in the UK as well. As the results have been coming through, a lot of interest from other water companies in terms of what's it looking like, what issues have we had to address. So certainly in terms of what we're presenting this afternoon, we've presented similar findings at a conference at Cranfield 4 months ago. And again, we're absolutely welcome to get as many of you to the Howden site to have a look at what we're doing, to get involved, especially as we are looking to take this to the next phase and hopefully get as much innovation as possible. So I'll hand over to Keith now, who will do the clever stuff of how the actual black box actually works.
Black box. Okay. So it's as Donna sort of showed in the photograph earlier. There's 3 principal columns in a container. It's sitting next to a return liquor tank, which is, I think that's taking around about 250-300 cubic meters a day. We're only treating around about half a cubic meter a day as a representative sample. It's running at about 3,000 milligrams a litre, or 3% aqueous concentration, but it's pretty consistent in terms of concentration, although we have had some quite high spikes, maybe say 4,000, but the system's sort of, basically handled that, no problem. So it's principally 3 columns, 3 packed columns. It's the main thing to remember about our system is it doesn't use pH. We don't adjust pH for the process. It's purely thermal. So we're not producing a salt, we're producing an aqueous ammonia. We're not adding acids. We're not adding any alkali to move the sort of ammonia coming out of solution. It's purely with heat. We aren't using waste heat at this stage. We're using electricity to drive the process, so that it's in the container. But the next phase that Donna was talking about, we are looking at waste heat utilisation on the site, and so there's plenty of heat available for us. So it's basically three packed columns. If you're familiar with sort of thermal stripping or steam stripping, a similar sort of sort of process, but we're effectively playing with the temperature. And as you can see in column 1, it's basically we're putting in the wastewater inlet at the top when we're driving up steam from the bottom, and moving into a concentration column, which is effectively cooling it. And then we go into the third stage concentration, the second stage concentration, third column, where we're effectively turning that into a concentration up to about 19%, sort of about 190,000 milligrams a litre. We've had higher concentrations. We can certainly do that. That's not a problem. Certainly in the lab, we can get well over 40%, even 50% at 10 degrees centigrade. But certainly at this, the target for us here was 19 to 20%. I think we've gone to the next slide. Yeah. So, well, there we go. So we're going from 0.3% to 20%. Part of the brief with the innovation project was to actually crack some ammonia, mix some anhydrous and crack some ammonia, which we did. We couldn't do that on site. It was principally obviously the health and safety and various sort of licensing issues for the site here. So we did that off site, but we certainly cracked it. I think the issue comes down to economics. Would it be viable to economically crack it on site on a full scale plant? And that remains to be seen. It comes down to the cost of the actual catalyst. We've had discussions with Warwick University about perhaps the next phase of sort of optimizing the catalyst. But at this stage, really, the prize is the recovering the ammonia and using that as a product, not really the hydrogen. The hydrogen is perhaps a bit of blue sky, but certainly something we're looking at for the future. So the various questions that we were seeking to answer was, what was the maximum concentration that we could recover? And I suppose that has to be said is, you know, is it sort of recover it economically? That's got to be the sort of main sort of proviso. And we, yeah, I think we're quite happy with 19-20%. Obviously, it's a function of the amount of energy that's available. We want to minimise the quantity of water in the product. But certainly 19-20% is a reasonable target, certainly saleable as a commodity as well. What can we recover most efficiently? That 19-20% is a good target. We're obviously looking at now scavenging the heat on the site. We're looking at a detailed analysis of available heat on the advanced AD system here, and the various engines that are on the site, the gas engines. That's the next phase. We're looking at additional sources of funding to go to the next stage of sort of integration. Let's call it integration studies. We'll look again. We'll look at the economics of cracking the hydrogen. I mean, one of the things obviously that we'll need to look at is how, the sort of work we'll need to do around the product, whether that be aspects of end of waste. We've got certainly early indications that we'll certainly comply. We've been working with Jacobs WSP in Cranfield to validate the results, and they're taking our report, and I think we'll be publishing that quite shortly, won't we? I think. Yeah. Okay, so some of the if you see, that's the sort of centrate, quite a nasty looking material, and we got the product there. Was that was the proof. And certainly we removed more than 95% of the ammonia from the return liquors. That produced around about 7 kilograms an hour of aqueous. So one of the things that we found was that some of the materials that we use without our knowledge necessarily in the factory in Thailand, when they arrived here. If we've got the next slide, I think we got the blue. Oh no, is that later? Oh, okay. I'll talk about that later on. So basically, again, no pH adjustment required to achieve any of that. So we proved what we said we'd do, and I think that was the main thing.
The one thing I think I'd add, Keith, is if it's a pilot plant, we are running at relatively low flows. We're running at 0.5 of cube per hour centrate. And the heat required for that 0.5 is significant. But again, as Keith's alluded to, we've got significant quantities of waste heat on the site. So even when we upscale it, we've got that confidence actually the waste heat will cover.
We did get the economies of scale at this sort of in this unit. So the mass balance, I can't actually read that too well, but it certainly we use electrical heaters, and we obviously use the heat recovery in the system a little bit to minimise the electrical load, but the cooling itself was using air coolers. Okay. Okay, so this is just reflecting the sort of the test conditions, sort of like during commissioning and during sort of steady state. You know, in terms of our achieving the 95% recovery, we sort of played around with the system and the temperatures. It took us a few weeks to get it up to optimal conditions, but when we did achieve optimal conditions, it was consistent, and I think we were quite happy with that. That it achieved, consistent.
And I think adding on to that, Keith, it was actually what's really surprising was how quickly the plant recovers. So these were planned conditions we were testing, and what's important to ourselves within Northumbrian is that in periods of downtime when we've got unplanned outages, we want to understand how quickly that plant recovers. So what we've got on from a process plant level is actually we've got a plant that performs in terms of the amount of recovery. It actually recovers in periods when it stops.
For sure.
This was one of the main parts of the trial that it really fills us with a great amount of confidence that actually it does work.
I think we can take the range, you know, if it was ranging from 1,001 cubic milligrams a litre to maybe 4,000 milligrams a litre, pretty well we can get into a steady state quite quickly. I think that reflects that, and again with the throughput can change, can't it? Quite on a regular basis. So we were quite happy that.
Yeah, and I think that's another key point as well, Keith, in terms of the period of steady state, the two graphs at the bottom, it is a period of steady state when it's up and running without these planned outages. It is maintaining that steady level of performance. Yeah,
and certainly, you know, generally speaking, I mean, processes aren't necessarily plug and play, but this isn't far away from plug and play. Clearly, there's some calibration required at the beginning, but again, that was part of the objective, to make it a relatively quick install. Okay, so again, this is just reflecting the cracking of the anhydrous ammonia. This was done in the labs at Warwick University. It was basically a catalyst that was selected by the university. That they've got a catalyst centre, and Professor Shanwen that we work with basically selected the most appropriate one that wasn't going to be really would certainly accommodate any contaminants that there might have been. But I think he was quite happy with the results, as you can see. Very consistent in terms of cracking rate. Might be one for you to elaborate on.
So the trial was run successfully from April this year, April 23, and actually by November, December, we were getting our wrap-up results on the trial. The results are promising. The plant ran stably. It wasn't left running in automatic at all. We always had that level of overseen by the organics team. Based upon the results so far, we have comfortably produced 20% ammonia from a 0.35% influence. So, and that is really positive. I think that's exceeded our expectations. I think what is really important to ourselves now is actually where is that sweet spot. So we know we can recover the 20% concentration, but is there a sweet spot where actually we can have the organics plant running most efficiently with an expectation that actually we don't need to hit the 20% mark. We might be happy with 10%, 15%. It depends on where that heat balance lies and how we can get that efficiency of scale. This is still work in progress, and this is what we're looking to work with organics on our next phase in terms of utilising that waste heat from Northumbrian Water's AAD plant. And we've got a schematic there of our AAD plant Sankey diagram. And we know that we've got 4.5 megawatts of waste heat available. Now, again, the devil's in the detail. We've got high quality waste heat. We've got quite low quality waste heat. It's going through area by area, and actually saying, well, actually, can we make this useful for the organics process? I think also we're looking at actually our current use of waste heat is to support the actually Canby process, thermal hydrolysis process on site. And again, what we're getting to now is can we adopt a different form of heat for the Canby process, and is it more viable to use it within the organics treatment process instead? Recognising that Canby was commissioned here at Howden back in 2011. Technology has moved on since those days, so it, in fact, from a thermal hydrolysis perspective, all of the heat recovery we've got on site is at best practice. Can we improve it? Can we actually increase that 4.5 megawatt to 6 megawatt? Because actually, by swapping out some coolers would release an additional amount of waste heat. And these are all areas that we're excited about, and we know that we can do things better. We're working with our strategic technical partner, Stantec and Jacobs, on this to look at how we can do things different. And hopefully this will come out of our Innovation Festival sprint. For being a biorefinery, it's looking at internally our internal processes and how we can do things better. So I'm going to keep on saying it. And I know that Matt, when you meet him later, he's going to be saying the same thing. Get involved in our Innovation Festival and how we can learn from each other to get the greatest results. How big is the prize? And this is where it gets quite exciting. If we can recover 100% of our ammonia from Brown Sands and Howden, we are confident we can obtain 4,500 tonnes of ammonia. And based upon current market values, we estimate that to be valued at £2 million per year. What are the economics of doing this? Have it great having the income of £2 million per year, but actually, what would we need to do with that? So we've got the waste heat, which again we're in the process of reviewing. From an organics perspective, they've estimated that each plant for the size that we require will be 5 million. So across Brown Sands and Howden, you're looking at a 10 million capex investment. Again, it's looking pretty positive at the moment. We've got the capex, we've got the 2 million income from the ammonia, but actually we also need to take into account our aeration savings, what that value of the carbon reduction in terms of process emissions. So at the moment we're sitting pretty cautiously. We're saying we've got a payback of less than 5 years. I think by default you can look at it and say it's going to be a payback of significantly less than 5 years, especially when you take into the value of carbon and our savings on aeration as well. We haven't given up on the idea of cracking to hydrogen. I know Keith is saying it's blue sky. Yes, it is. It's that next phase, but actually we don't want to lose. We don't want to be losing that. We are continuing to work with organics and Warwick to see actually what is that real economics of cracking. Actually, is it best? And it comes to that value from ammonia. Is it best marketing that ammonia as a fertilizer, for example, or is it actually best marketing it as a precursor to cracking to hydrogen? And again, these are all things that we're looking at. Scalability. So at the moment we've got a plant that can operate at 0.5 of cube per hour. Our final process plant at Howden and Brown Sands, they're going to need to be operating at about 250, 300 cube an hour. So again, we are very small scale at the moment. Small scale at the moment, but using an inefficient mode of heating. So again, we know that we can do things better. And we also need to obviously look at the overall impact of ammonia recovery. We know that with the tighter consents that's going to be hitting us, we know that actually taking that ammonia out of source can only be a good thing. So what we've been working with within Northumbrian with organics since 2021, and we have learnt lessons from each other and shared those lessons already. So I dare say one of the biggest comedy factors, and again, organics.
We did this on purpose for the test.
It didn't phase organics at all. That certainly caused a few alarm bells to myself. So you can see the vial on the left hand side is the influent, our process liquors from our AAD plant. And then what initially came out from the organics plant was a solution that was bright blue. Now, ammonia isn't bright blue, we knew that, and I'm a chemist, so you can automatically see that that is...
Didn't get away with it, did we?
You didn't get away with it, Keith. You almost could have done, as pesky kids say. But we know that there's corrosion of the organics kit that was supplied from Thailand, obviously containing high amounts of copper in there. Again, organics wasn't phased by that. They very quickly identified the source of the problem and then very quickly swapped out those components. And again, that allowed us then to demonstrate that actually within the matter of weeks, we were producing that high quality ammonia liquor from our AAD return liquors. So yes, it was lessons learned. Yes, it was unfortunate we didn't foresee it, but what was really positive is how quickly organics reacted to that. In terms of other not surprises, because they were expected, was additional carryover we get from the dewatering process here at Brown Sands and Howden. So yes, we were able to recover the ammonia. However, there was carryover of other materials from our dewatering process. Now that could have been components from our polymer we use for dewatering, or it could be within the effluent stream itself. So we experienced high levels of VOC, sodium chloride, and various other metals and organics. Again, relatively low, but from having a product that we can market would be unacceptable. Now again, organics didn't shy away from this quite quickly. You came up with an alternative.
Yeah, in terms of distillation, with doing distillation and certainly increasing the retention time, we've sort of got the really down to trace. But ultimately, at the end of the day, we need to match the requirements of the product, whatever the saleable product requires. But we're confident of producing a saleable product within range of requirements. So we've now solved the problem of carryover, which is good. We've got that additional distillation stage. I think another great example of how we've been working together has been the collaboration. The trial started in 2021. Neither Northumbrian Water or organics gave up on it at all. We knew we had delays for valid reasons, but since organics arrived on site earlier in 2023, we have absolutely delivered some great results. It's been a real example of collaboration. Great teamwork between organics and Northumbrian for myself within capital delivery. We've involved our engineering teams, we've involved our operations teams. And I dare say, a specific what we've got here at Howden, we've got our scientific services, which is our lab here at Howden. And we've got some great equipment on the lab here. So as an example, when we started experiencing the carryover of material, immediately we said, well, actually get it to the lab, run it on mass spec so we can actually see what is being carried over. And it's been that continual teamwork between ourselves and organics that's allowed us to do that. And again, we know that we need to solve so many issues as we've been working through that. We've thrown everything at this to make this a success. So what comes next then? So we've already had this since 2021, a roadmap of how we got to where we get to. It's been the design and procurement of the equipment, getting it to site, organics and Northumbrian Water working together to optimise the plant as far as possible. But we're not there yet. And again, we know that we're about to embark on phase 2 of the project, which is going to be delivered by organics and Northumbrian Water. But again, we welcome input from other organisations as well. We need to get more operating hours. So one thing we wouldn't allow organics to do would be to leave that kit unsupervised. So the maximum operating hours is 8 hours per day. Again, we want to get to the position where we know we can comfortably leave that plant running 24/7. We want to have that tighter control with ammonia. So we want to understand where that sweet spot is. Aiming for 20% is great, but if that's not the best position economically, we need to improve on that. We need to get that plant running in automatic. And again, we're looking at refining the algorithm for the control system in the plant.
We need to look at mitigating the carryover of contaminants. So we've got that additional distillation phase. Is that the best way of dealing with contaminants? There is an alternative. And we need to understand the nature of the feedstock and how it impacts on our process. And again, this will dictate how big that prize is. At the moment, we've got some pretty casting assumptions in terms of what the impact on aeration will be, but we need to actually quantify that. And then, as I've already alluded to, we want to make use of our waste heat on the AAD plot itself. So what's coming up next? We are gearing up for implementation. We know that we've got a more detailed design. We want to switch out the electric heaters that organics are currently looking at and make best use of that waste heat. We want to have a plant that can deliver 250 cube per day automatically, and I think that becomes a key point for us to have a process that we can sell to our operations team. This is a process that relies upon heat, high pressure, all things that we've got experience of within here at Howden by virtue of our thermal hydrolysis plant. But again, we want that plant to be operating on automatic. We need to identify more routes to market. So again, Keith and I are working on who could be that end user for ammonia. And as Keith's already alluded to, we've got to look at how we're going to arrive at end of waste status. And then we've got to develop and get approval of our business case. At the moment, we're proposing that this will be a spend to save project within Northumbrian Water, and it will be led by efficiency. And based upon the results we've seen so far, that looks to be the position where we're going to be in. In terms of the UK market and carbon, we know that process emissions are now getting looked at, always have been, but more so now through a different lens and a tighter lens. And we know that actually there is a value to those carbon savings. Again, we need to wrap that up within the business case. And then also in terms of our future looking of consent, we know what our AMP8 enhancement programme looks like. We know that we've got tighter ammonia consents that are coming. We know that actually in future AMPs, they're only going to get tighter. And actually, we know that actually this is very much focused on ammonia and how we need, as an industry, we need to do things differently.
Okay, thank you, Donna and Keith, for a great presentation so far. So we are just going to go to a quick 15-minute break. So feel free to keep popping questions in throughout the chat while we're on our break, and we'll be coming back to hear from Matt about further projects available at Northumbrian Water, followed by the question and answer session. Okay, everyone, so welcome back from the break. Just before we go into the Q&A, we're just going to hear from Matt Pickersgill on the future projects at Northumbrian Water.
Good morning, everybody. So yeah, thanks, Leah. I'm going to talk about the other relevant technologies and innovations that we're looking at in the same space as the organics process. So the first technology I'm going to talk about is the Green Machine project. This process is again looking at digested sludge liquor, which, as Donna identified before, there's a massive opportunity for product recovery and process optimization, especially as we go into AMP8 and we're looking at process emissions, carbon reduction, and lower power and chemical consumption. So the Green Machine, as its name suggests, is a microalgal based technology. It uses algae to consume nitrogen, phosphorus, and trace metals, which thankfully the sludge liquor is a fantastic source of. We discovered this species of algae. It's a genetically unique species at our Brandsands treatment works in 2016. We have been through the last 4 or 5 years of process development and optimization. We've worked with partners in the algal industry and Newcastle University to develop a process, pilot scale process at 1200 litres. We are now constructing a demonstrator scale process to deal with 5,000 litres per hour of digested sludge liquor. So this represents around 10% of the digested sludge liquor flow that you would get at either Howden or Brandsands. So some key process statistics, we can convert 10 kilograms per hour of ammonia into proteins. Those proteins can then be used as sources for fuel production, such as biofuel, sustainable aviation fuel, etc. We can consume 1.25 kilos per hour of phosphorus, so that can then be mined and recovered. Again, this goes back to NWL's focus on circular economy and how we can utilize the sludge liquor stream is a source of product recovery. The process also requires carbon dioxide. Algae requires CO2 as a source of carbon, and it also requires pH correction. So we can achieve both of those with a consumption of CO2. Thankfully, due to our AAD and gas to grid operations, we have a ready source of CO2 available and waste heat, both of which will be utilised in our demonstrator scale plant. We can convert 90% of the ammonium in the sludge liquor into proteins, and 65% of the phosphorus is consumed. So, small graphic of what the solution looks like. So the image on the left is the organism, which is a genetically unique strain. And the photobioreactor is one of the elements of the process which we have developed in-house ourselves for this specifically for this application. The second technology I want to talk about is one that is not new to the water industry, but it is relatively new to the UK. So this is called the mobile organic biofilm, or MOB. This process originated from the United States. And we are looking at this technology as a way of increasing capacity in our existing aeration lanes. So the technology works by introducing a biological product called KNAF, which is a milled plant. This creates a matrix within the activated sludge plant that allows a greater density of biomass to grow, so you can get more capacity out of your existing assets. This has numerous advantages in that we don't have to have more embodied carbon and concrete construction. We can utilize what we have, so lower capex. We can also use this technology where we have carbonaceous works to partially nitrify or fully nitrify, and that we've spent the last 12 months pilot trialing this with potential application at our Howden sewage treatment works. This technology is also being looked at for our future total nitrogen trials, which were required in the industry to undertake to understand what the technically achievable limit is for total nitrogen removal. So the process is pretty straightforward. We have the aeration lane. Into the aeration lane, we add the KNAF, which is the milled plant product. This is retained within the aeration system. It passes through the standard activated sludge process. The only additional component we add is a rotary screen. The rotary screen is used to retain the KNAF material within the activated sludge, and it's not then wasted out through the surfacing system. The next technology is going to be talked about in another spring showcase. It's called Superloofah. So this technology is being developed by Newcastle University and Northumbrian Water, and it was subject to Ofwat innovation funding. I'm not going to go into any detail about the phosphorus project because that will be subject to the next showcase. However, the one thing I want to touch on is the ability for this platform and how it can be used for other nutrient recovery as part of our approach to the circular economy. The innovation of this process is that it uses a loofah, which is a waste product, and is then impregnated with algae and coated in a biopolymer. That polymer allows nutrients and liquid to pass through, but prevents bacteria and also prevents the algae from being washed off. So these solid state, this media is then packed into tank reactors, as you can see in the diagram, and then we use artificial lights to allow the algae to photosynthesize. This application is for final effluent, and it passes the final effluent passes through the reactors, and as it does so, the algae will take out the nutrients. The primary goal of this first trial was for phosphorus, but we know due to the function of microalgal cells, they will also remove other nutrients such as nitrogen and trace elements. Inside the reactors are LED lights. These will provide a source of heat as well as allowing the algae to photosynthesize. And surrounding those light tubes will be the biocomposite media, which is made up of the loofah and algae biocomposites. And just to add to what Donna was saying earlier, in that all of our technological innovations, likes of organics, algae, are focused on the circular economy and nutrient recovery, so we can not just monetize but have a more sustainable wastewater treatment process. We'll be running an event at the Innovation Festival this year, so I'd encourage anybody who's interested in the circular economy and the types of technology that we're looking at to sign up and come along, because we want different voices in the room, and we want cross-industry support for in collaboration on all of these projects. And that's how all of these projects have been a success. None of them have been just Northumbrian Water Group or just a technology provider. It has all been successful because of collaboration. And that's everything from me. Thank you. It's back to Leah.
Hi everyone. So thank you so far to all of our presenters for the excellent information they shared today. We'll now be going into the question and answer session. So please do keep putting questions in the chat as you think of them. Okay, so first question is for Donna from Steve, who wanted to know, how regular is the downtime? Obviously, if performance does drop off regularly, that could result in shock loads back to the work if there isn't insufficient buffering.
So it's a really good question, Steve. So certainly we'll be looking for the process to be viable. It needs to operate in automatic and have a high level of reliability. That saying, we do recognise this will be a relatively high pressure system that needs to operate, so there will be statutory inspections that we're going to need to complete. We can manage that. And in terms of our effluent treatment works accepting those shock loads, actually we know from setting up AAD when we commissioned that back in 2009, the shock loads of the increased ammonia, it was accommodated. But we want to avoid that as far as possible. So we'll be working with organics in the coming months to say, actually, what buffering do we require? What is the impact on our effluent treatment works? What is the impact on our commercial business case in terms of downtime? So these are all things that we're going to be working through to make sure that we end up that our compliance record isn't impacted, but also in terms of the commercial viability of the system, we can manage that. I don't know, Keith, if you've got anything else to add on that?
Just, I mean, our normal downtime in it's a similar process, but in terms of stripping out, we got very limited. It's the limited cleaning requirement, sort of taking out media, etc. But it's a quick change, so it's very quick. And
I think as well, to add on to that, in terms of the organics design, there isn't actually many moving parts. So in terms of unplanned outages, they should be relatively minimal. It would be my biggest concern would be that statutory inspections that we're going to need to complete, and how do we actually minimise the impact of that. That's saying that's exactly what we do within our AAD facility. We have statutory inspections of our thermal hydrolysis plant, and we now complete that in record time. So yeah, our downtime, we've got good experience of that within Northumbrian Water, how we can minimise that impact. I think we already have, sorry, Kate, we already have those downtimes. So when we have our thermal hydrolysis plant shut down, the plant may be off for a week, 2 weeks. Actually, that shock loading would happen because our AAD return liquors dewatering stops at that time as well. So from a process compliance point of view, not overly concerned. It's more about the commercial business case.
I was just thinking maybe the front end sort of primary stripping phase, you might have, say, standby duty or something like that. But that's part of the next phase in terms of detailed design.
Perfect, thank you. And another one for you, Donna, from Chris is there any indication of feed buffering requirements at full scale? Does the plant operate best if running continuously 24/7?
So that's again another really good question. So we are looking at buffering, what buffer storage we would need, if we potentially could have to minimise that impact of downtime. I think back to Steve's question, if we're looking at a shutdown of 2 to 3 days for statutory inspections, realistically at a flow rate of 250 cube per hour, it's not realistic to have a buffer storage tank that size on site. But we would be looking at buffering. We could actually include within that design. This is all part of the next phase of the project, really, is to work through that to make sure we get that design that's fit for purpose.
Keith, did you have anything to add to that? Or?
No, I think
no.
Perfect.
Perfect. So one for both of you from Z is, if pH adjustment and or vacuum is applied, will that deliver any saving on the thermal energy usage?
Yeah, so one thing that sets us aside within the organics process is not having to rely upon chemicals, and that was one thing that really attracted us when we attended the conference at Cranfield. There was tens of other ammonia recovery treatment processes, all claiming the same sort of performance, but our key differentiator was not relying upon chemicals. That, as a business, that's really important for ourselves from a circular economy point of view, that we don't want to have that reliance on chemicals. The point on the vacuum is a really good point. And again, I left that the conference in Cranfield thinking actually we could end up with a hybrid facility where we rely upon temperature, but actually by the small introduction of a vacuum technology, we actually are able to reduce our OPEX. And again, this is all things that we're looking at in the next phase. So yeah, absolutely an excellent point on vacuum. Good point on chemicals, but we'd like to avoid it if we can.
Perfect, thank you. Keith, do you have anything to add to that?
No, that's good.
Fabulous. So another one for you, Donna, from Geraldine is, what is the technology readiness level for this process at full scale? Is there more development needed to be able to treat 100% of the liquors at Howden, or would this never be the aspiration?
The answer is yes, we would. From an AAD liquor perspective, that is the aim, to treat up 100%. That's where the real prize is. On site at Howden, as part of our bioresources area, we've got other dewatering areas. We've got drum thickeners on site. We've got centrifuges on site dewatering the bioresources that goes into our AAD facility. Now, relatively speaking, they are lower in ammonia, so the prize isn't there. So in terms of dewatering our liquors, it would be absolutely definitely within our AAD, post AAD, not necessarily pre-AAD. However, depending on when we get to the next phase of the project and the efficiency of the process, we could find ourselves looking at actually what are the other sources of ammonia and how we can extract it. I think more from an ammonia point of view, it's the great work that Matt's working on in terms of the other processes we're looking at and how we can remove ammonia from other parts of our wastewater treatment process. But yeah, the answer is absolutely 100% AAD. In terms of technical readiness, Keith?
TRL9, I mean, for none of the technologies that we're actually using on their own aren't TRL9, so we're integrating obviously principally three different technologies in the system. But in terms of saying whether it's TRL9 or somewhere else in the ranking, yeah, we see it as TRL9. If you like, the guts of the system has been operating in Hong Kong for 20 years with some fairly robust clients and quite a highly regulated environment. And it certainly works. So we're
Perfect. Fab. So Falani just wants to know, what does 0.3% input ammonia mean? How does it relate to concentration from AAD liquors?
So 0.3%, that directly relates to the 3,000 milligrams per litre ammonia, and that is when it comes to wastewater. What we report, we tend to report in milligrams per litre. 3,000 milligrams per litre is 0.3%.
Perfect. Fab. And she also wants to know, is there capacity to recover other materials such as phosphorus?
So I think Matt alluded to that in the follow-up part of the presentation.
Yeah. So this process is focused only on ammonia and recovery of ammonia from such liquor, but yes, we have other technologies that we're looking at, such as superloofah or microalgal based technologies that probably allow for that recovery, but just in using a different process.
What I'd also add on to that is actually come along to Northumbrian Water's Innovation Festival, because this is what the biorefinery Spring is going to be looking at, how we can look at our whole wastewater treatment process and how we can maximise on resource recovery and get all the things that we know there is value and actually get them in the right state so we can actually market them. So again, phosphorus is a key area. We've been looking at phosphorus for many, many years now. We've got it within our struvite, we've got it everywhere. So it's how do we maximise that and get that maximum amount of recovery. But yeah, please come along to the Innovation Festival.
Perfect, amazing. And then could you please expand on how you would implement this project within your organisation? So I think you've touched on it briefly in the presentation, but if you've got anything else you'd like to add at all, or?
Yep, so the next phase of the research, that is where we're going to really test this in terms of, can it run an automatic? The answer is almost certain, yes, it can. The biggest thing we need to work through is on the use of our waste heat. So we know that this process, in the earlier slides, I indicated what the power demand of this is. We know that for that to be truly viable for Northumbrian Water, we need to absolutely maximise the use of the waste heat from the AAD facility. Once we've done that, and once we've got that design in place, actually we can demonstrate that actually organics is a process where actually the OPEX cost of importing power is zero because we've got the waste heat, then it becomes absolutely truly viable, and then it really is going to be implemented widely. We're lucky within Northumbrian Water. We've got two regional treatment centres here at Howden and Newcastle and Brandsands and Teesside. That means we only need 2 organics ammonia recovery plants. Both will be sized at about 250 cube per hour. Not massive by any stretch. Certainly if the results of the next phase comes to fruition, there's no surprises in there, which we don't believe there is. Certainly immediately after that, we'd be looking at implementing at full scale.
Fabulous, wow, exciting. Fab. So some questions that have come in privately to us throughout this sort of Q&A session so far. Oh, no problem. So great example of circular economy. What else are you doing in the circular economy space?
So again, back to our environment strategy, circular economy is absolutely up there in terms of what our key aims and objectives are. I'm personally on programme lead for the Aqueous big question, which is really focused on resource recovery and circular economy. Our innovation festival this year is very much targeted on circular economy. We're looking to start measuring, as every other water company is, we need to measure how circular we are as an organisation. That's across our water and wastewater process. But yeah, so we've got some other great examples of research we're implementing that's going to support our ambitious goal of being truly circular.
Yeah, and that's recycling things from material we recover from grit screenings into things like concrete blocks, all the way to what we recover from our such liquors in the end of the process, but also what comes out of the final effluent as well.
Fabulous, thank you, Matt. So one for Keith, I think. Process has high resilience on waste heat. Will this be suitable for non-AAD sites?
Well, if there's available waste heat, say out of a gas engine or whatever, then certainly the sufficient heat out of a Jan Bakker type engine. So on a landfill site or on a typically that's where we've seen them. But if they are available on conventional wastewater treatment plants, then yes, that should be a problem. It's just down to the quantities of it's a heat mass balance. So I guess we're happy to take a look at those sort of things in on a standalone basis. They should work.
Perfect. And what other work is there that organics are working on, and what's coming next for organics?
Well, we've touched on it with Northumbrian Water already and a few other water companies. But a big part of our focus at the moment is pyrolysis. So we're using it basically that to treat a range of different feedstocks, and now investigating sewage sludge. And sewage sludge has clearly had a history with thermal treatment, but in terms of pyrolysing relatively small quantities, it does have a potential use as a sort of carbon dioxide its sequestration potential. We're doing a lot of that work at the moment as well in Southeast Asia in particular. Big focus of ours at the moment.
And that becomes really important for ourselves for the water industry, where we know in terms of potential future constraints on our recycling routes, we know that as an industry we need to be looking at alternative options, and that absolutely feeds into that area.
Absolutely, perfect. So Steve has asked 300 megalitres is a relatively high end level. What is the lowest viable level for the technology?
In terms of concentration?
Yeah.
Well, in somewhere like Hong Kong, we're operating at around about, lowest is about 800 milligrams a litre. We can operate in terms of ammonia concentration. Sweet spot or anything higher than maybe 1500 is easy for us. The larger the better in terms of concentration level. But yeah, we could call it 1000 to 1500. It depends on volume and available heat.
I think another important consideration there is, yes, it might be technically viable at 800, or
It's commercial.
but commercial, isn't it? In effect, all you're doing there is heating up water.
Yeah, heat
Which,
water. I mean,
again,
we do it
when-
500.
Yeah. When you look at our AAD process, we've spent a lot of time actually refining our feed rates, because we do not want to be heating up water for the sake of it.
Yes. Yeah, absolutely. And is there any sort of mitigation you put in place to ensure that you're not kind of heating up water with?
Purely our control system, so it's about getting our pre-dewatering absolutely finessed, that we can guarantee that what comes out is 16% dry solids. That is a key part of our control system. And then similarly for the organics part of the process, what we need to really ensure there is what comes out of our post-dewatering is up at 28-30% dry solids, and actually that feed rate of 3000 milligrams per litre is pretty consistent.
Perfect, fabulous, thank you. Okay, so another one that's been sent directly to us. So where is the market for ammonia?
Well, as in terms of in the UK, it's principally fertilizer. There are potential producers and intermediaries in the fertilizer industry that are interested in the product, assuming it achieves its end of waste status, and also in terms of gas cleaning. So what typical municipal waste incineration plants that use it in gas cleaning is a typical sort of use, maybe for bulk in the UK. But yeah, there's a multitude of potential avenues for it.
Perfect. And then another one for Donna is, what are the expected OPEX savings if we can remove ammonia at source?
So I think I alluded to that in the presentation. From the biggest OPEX savings, obviously, as well as the marketable value of what the value of the ammonia is, and we're saying that's approximately 2 million for the volumes we expect to be producing. We're looking at about £500,000 OPEX savings from our electricity savings from our existing treatment process. And in addition to that, it's the value of carbon. So if we can reduce our process emissions, that has a carbon figure attached to it. And again, it's the value of that and what do we put against that. Where from an Ofwat perspective, this AMP, as in 2020 to 2025, we're incentivised for that carbon reduction. We've got the Ofwat carbon accounting workbook that's going to become more developed. So actually, the process emissions become more finesse, and then we then have to report a more finesse figure for that process emissions. So yeah, I think it's a bit of a let's see what happens, but we know that the process emission side of things will have a significant carbon value attached to it.
Especially as we're moving to AMP8 and we get the same for nitrogen emissions from our processes.
Yeah, no, exactly.
Perfect. And Donna, will the Organics Prize offer planned environmental drivers?
So yes, there's certainly we see it as a massive contribution. So if we can deal with our ammonia opportunity, then from our environment strategy point of view, in terms of resource recovery, yes, that really helps us along the way. That saying, we know we need to do more, and again, we're looking at the whole water and wastewater treatment process. So yeah, it's very much focused on resource recovery. It could be a simple thing, as Matt's alluded to, we've got wastewater screenings that are currently going to landfill. We know we can do things bigger and better, and again, I'm working with Upwear on that in terms of what that future may look like. From a grit perspective, we're really lucky within Northumbrian Water.
Mm.
We recycle all of our grit arising from wastewater. That isn't the same for many other water companies. But that luck is only going to be short-lived. So it's going to land reclamation. We know that's not a long-term viable solution. We know that we need to be more circular in that and look at what good looks like. So yes, ammonia is definitely going to contribute to it, but it's not everything. We are looking at the whole wastewater treatment process and our water treatment process as well.
Perfect. And what other areas of are Northumbrian Water exploring to improve its performance in the area of bioresource?
So we're continuously improving. So we are really proud within Northumbrian Water that we are the highest performing water company in bioresources. We are looking at modifying our existing AAD process to obtain up to 10% more biogas. That's something we're actively pursuing now. That becomes really important from a process emission point of view. So under Industrial Emissions Directive, which is impacting on every water company, to be back, we know we need to reduce our process emissions. If we can actually convert more organic material to biogas and biomethane, that allows us to reduce our overall process emissions. And also be fully compliant with Industrial Emissions Directive. So at the moment, we're looking at installing a particular process on our thermal hydraulics process and our AD facility to get that increased level of biogas. Continuously looking, and again, I'd encourage you to come to the Innovation Festival because this is an area, again, we're going to be looking at in terms of what does our wastewater treatment process look like. We're also, we've been actively trialling other AAD related treatment processes where we can abstract phosphorus, where we can abstract, make best use of CO2 and everything and to maximise that methane production.
Perfect. I think, Keith, you might have already touched on this, but we have had another question asking how is the recovered ammonia typically utilised? I think, have you already touched on that?
Yeah, well, we did.
Yeah.
I mean, yeah, multitude of, I mean, it's obviously very local to perhaps whichever territory you're in, country or region, but it is a generally speaking a commodity which is utilised quite widely. And certainly in the UK, lots of uses for fertilisers and, as we said, in gas cleaning in particular, that we've already had discussions with people about.
Perfect, thank you. And someone else has asked, given the success of initiatives like the Organics Ammonia Recovery Project, could you provide insight into any ongoing or planned collaborations, research or investments that Northumbrian Water is undertaking to further enhance its bioresources management capabilities?
I think I can pick that one up. So I think some of the technologies I alluded to, ones that we've either identified, developed ourselves, such as the green machine process, or collaborations on phosphorus or metals abstraction from sludge liquor, our research interests in terms of what we're doing with PhDs are looking at how we can make better use of our waste heat. What is the value in some of the more interesting compounds that we have in some of our wastewater streams, and then going down the route of looking at things like PFAS and those more complicated questions that we need to answer, and how that focuses on our bioresources, of those biosolids that we send to land, and then what the ultimate aim for that is once with changing regulations and lack of routes to land.
Yeah, and I think in addition to that, we've got the great work we're doing with aqueous. So there's 2 research projects that are ongoing at the moment in terms of bioresources strategy, and then obviously in terms of our clean water process, how we can have best use of our clean water sludges. So again, both looking at bioresources. So and that's a really example of collaboration. The work we do with aqueous, supported by every water organisation, is yielding great results.
Fabulous, that's great to hear. So another question we've just had is, how do these endeavours contribute to Northumbrian Water's overarching goals of sustainability, environmental responsibility and delivering value to its stakeholders?
So absolutely, by default of circular economy, it feeds into that. So everything we do is aligned to our long and short term goals. Absolutely, it's for the benefit of our customers. If there isn't that market for ammonia, then the business case wouldn't stack up and it won't be progressed. But yeah, certainly we believe this is a really strong contender, how we can support the environment. and most importantly, keep our customer bills lowest.
Yeah, and we do that by not producing waste, by turning those wastes into products that we can either sell or that become useful products that society can use, and they're not sources of waste that we're putting into the environment in one way or another.
Perfect, great answer, thank you. So Adam just wanted to ask, how does the cost, financial and environmental, of stripping the liquors for ammonia stack up against other sources of ammonia used in industry?
So we're looking at, in terms of the payback, we're looking at significantly less than 5 years. And again, we're looking to progress this as an efficiency project, and if it meets the criteria of payback within X years, it will be progressed. If there was a better use of ammonia in industry, then that would be considered as well. But at the moment, based upon the waste heat we have available here on the site at Howden and Bransands, we believe this to be the most viable solution, I think.
Absolutely. Somebody else has asked, can you elaborate on the strategies for maximising the utilisation of waste heat from the Howden AAD and how they align with sustainability goals or operational efficiency targets?
Yep, so this is an ongoing piece of work. So as part of the presentation, and I didn't go into the detail of it, but if anybody wants any further information, we can share that with yourself. We presented that Sankey diagram, which absolutely shows the heat balance across our AAD facility. I also alluded to the current design of AAD that already uses our waste heat in terms of steam production for thermal hydrolysis. And again, we're looking at reviewing that to say, is this the best use of that available waste heat? So again, it has to be completely aligned with our sustainability goals, completely aligned with our environment strategy, and completely aligned to what commercial opportunities are available at that time.
I just say that we're using low grade waste heat. I mean, there's so in terms of low grade waste heat, so 70 to 90 degrees. Yeah.
Perfect, thank you. And could you elaborate on the collaborative efforts involved in this project, including the roles of Northumbrian Water and its partners such as Organics Group, Anglian Water Services and Cranfield University?
Yep, so that work is ongoing. So certainly in terms of the key players, it's been Northumbrian Water and Organics. We have so Organics, Anglian Water that has been involved since day one. We do need to improve on that. So we're certainly, in terms of this next phase, we are going to be reaching out to water companies to get their involvement, obviously including Anglian Water, because they were committed from day one. There is still some work to be done in that area to get that level of involvement. In terms of the work from Cranfield, we've been consulting with Cranfield again since its infancy. We're now in the process of this final review. So Organics have completed their final report, and we're looking at getting that final report reviewed and get that challenge from Cranfield, WSP, Anglian Water, Jacobs and our other technical partners to make sure that actually by the time we've issued that final report, with confidence we can say this is the right technology for the water industry. But again, we are looking at that, and an example of that is what we're doing today. We're cascading this. Hopefully on the call there's people from other water companies on there. Absolutely welcome for any of you to come to the Howden site to learn more about Organics and get involved. This is not a sprint. We know that we are away from having that plant that will be fully installed. To get more people, more organisations involved in this next phase of delivery can only be a good thing. What we don't want to do is miss out on anything that we're not considering ourselves. So in terms of collaboration, yes, please get involved. Maybe an ideal platform is to come along to the Innovation Festival, because then Matt, Keith and myself will be there leading this sprint. And it'd be good to hear about everything else we're doing within Northumbrian Water and get involved with what we're doing here at Howden as well.
And what date is the next Innovation Festival?
It's the 8th to the 12th of July.
8th to the 12th of July, perfect. So in terms of actually collaborating and implementing this project, are there any sort of key job roles that you think were kind of involved in this that you definitely need there if someone was to try and implement this at their organisation?
If you want to start, and then I'll
So key job roles.
Yes, yeah. So who are the kind of important figureheads that you need to be able to implement this?
Oh, well, definitely a good project director. I think at the end of the day, somebody that really knows the organisation, how things work, and Donna definitely knows all the people was able to corral the necessary resource together and just point us in the right direction. I think what Donna said and Matt sort of said it throughout, I think, is that it's been a really collaborative approach. Like none of the other projects I've really been involved with. You know, it's been very much an open door. You know, we've had our own paths. We've been able to work with everybody from the guys on the gate to, you know, everybody throughout. So it's been a real, you know, collaboration, not to the extent, you know, it's almost feeling like part of the furniture. But it has been a really good integrated approach. But so I think that once we were sort of like, it was set out the management team who would be involved and we were pointed in the right direction, it just seemed to sort of flow. And we've had lots of, you know, regular meetings pretty well throughout, so everybody knew what was going on. There were no surprises. Everybody was kept up to speed.
Well, I think a real element of that has been actually, we were so pleased when the kit finally arrived in the UK. And this research actually commenced in 2021. It took until 2023 to get here. We maintained that sense of humour throughout, Keith. And so when it came here on site, we didn't want any.
That's good.
we didn't want any blockers at all. So we put absolutely everything in it in 2023 to make sure that actually all of the Northumbrian water resources were available. Also bringing into that, we've obviously collaborated with Warwick University. Again, we want to make sure that when that final report has been issued, there aren't any surprises in there.
Absolutely. Okay, perfect. And then another question has come in. Are there any specific metrics or benchmarks used to measure the economic viability and competitiveness of this approach?
So yes, we've got a value framework. There's a value to everything. So even down to the value of carbon, that will all be taken into account. And ultimately, the business case will stack up on the value of these various elements and arriving at that acceptable level of payback. And also taking into account the business risk as well. So one thing we can't tolerate is a risk on our compliance. That's what we're here as a primary reason. We're here for wastewater treatment, and the other elements need to stack up. But we are embracing circular economy. This is absolutely resource recovery at its finest. There is value there. It's a simple technology. We've got the waste heat. Based upon what we're seeing so far, we can't really foul. We've got to focus on the end of waste criteria. So if we can't work around that end of waste criteria, then we haven't got a product to market. So there's some still things that need to be worked through, but in terms of a business case, it's aligned to our values framework.
Perfect. Fab. And upon reflection, what was one of the biggest challenges you faced during this project other than COVID?
I think it was COVID, wasn't it?
Other than COVID, obviously the Ukraine situation didn't help, and that did slow down sort of a lot of traffic in terms of shipping, and you know, to be fair, I think it might have been, you know, 6 weeks on a boat, or maybe 6 weeks at Teesport, but purely that's because a lot of the freight got backed up, and so there was a lot of, you know, like unforeseen situations like that we. You know, luckily we came into Teesport, which isn't too far away, and we were able to expedite things. But yeah,
so we may as well blame Brexit as well, then people.
All of the world events. Perfect. And is there any other challenges that stand out to you that you kind of really have to come together as a team to solve?
I don't think so. I think we've really, because we've had quite a small dedicated team working on this, even when the process plant had elements of copper in there that was causing us to scratch ahead, it was resolved really quickly and painlessly as well.
I think we've sort of just kept hands on. We haven't sort of walked away from it or forgotten about it. It's been and the fact that a few of us live very local as well has probably helped a little bit. But the company's definitely been sort of very hands on.
I think another element we've not really touched on so far is health and safety. So this is a high pressure system. And again, we involved the right stakeholders within Northumbrian to give us some confidence that yes, albeit this is a pilot plant, actually it will be upscaled at some point, and we want to make sure we've got a system that we can actually safely operate. So that's been absolutely front of mind all the way through.
Perfect. And in terms of the pilot plant, was there any specific reason why Howden was chose to be the pilot plant for this project?
It could have been either Howden or Brown Sands.
Okay.
Again, here at Howden, we had the space available.
Mm.
And it was ideal. It was next to, I suppose, the return liquor tank. It was just convenient, I suppose, was it?
Yeah, I think so.
Yeah, it's a choice of one or two, isn't it?
It is really, and I think what Matt's we've got a lot going on at Brown Sands. There's a lot of other research areas at Brown Sands, so it's again also at Howden we've got a capital scheme ongoing which is looking at increasing our flows through the work. So again, to give us that confidence that potentially organics could be a contributor to that ultimate design, it seemed an ideal opportunity to get it trialled at Howden to support that wider project we've got ongoing anyway.
Perfect. Thank you. Did you have anything to add to that, Keith?
No.
Sure. Perfect. And what specific benefits does the conversion of recovered ammonia into hydrogen fuel offer in terms of reducing emissions and improving ecological status, particularly for rivers and surrounding environments?
Well, it's rather like removing the ammonia in the first place. That's going to be the primary thing. Clearly, if you can do additional added value by producing the hydrogen and increase the revenue potential of the recovered ammonia, then that would be the real driver. I mean, first and foremost, you're removing the ammonia. So in terms of the environmental impact, clearly it being used as a green fuel, as a hydrogen, would be a prize. But clearly, it's cost of production is key, and that's what ultimately, it would be what we're interested in doing.
I think so. So in terms of the environmental benefit, you'd have to be looking at all of the viable uses for ammonia. So we could end up in a position whereby ammonia is used for the production of fertilizer, but that process itself is of lower environmental value. Yet the environmental process of using that same ammonia feedstock to produce hydrogen, environmental impacts that needs to be assessed throughout the next phase of what those viable uses are. But it will also impact on what that commercial business case look like as well.
Perfect. Amazing. So I think that does bring us to the end of our question and answer session, unless you guys have any sort of final thoughts you wanted to add, or
I think the only comment with doing any sort of projects like this is that I think Donna and Keith probably agrees the involvement of operations. If you want to do stuff like this on a works, and you need their buy-in, and you need to get them excited about the project, whatever that is.
Yeah, and they have here at Howden. So like all of our wastewater treatment works within Northumbrian Water, the operators live and breathe this, and it's a really good point, Matt with them. They live and breathe this all day long. They see a container arriving on site. They want to know what's going on from a health and safety perspective, but actually what's coming next. And so all the way through, what we've spent time doing is actually working with operations, not so much in terms of the doing, because that's what organics are looking at, but actually what is that longer term impact going to be on operations here? Taking that into account, that's where we get to actually it needs to work in automatic. Everything that's pretty obvious really, but we know the importance of these things.
Yeah, there's been a lot of genuine interest from a lot of the operations folks. Really.
And I dare say here, particularly at Howden, but any wastewater treatment site, it's the impact on odour. So again, we are extracting high strength ammonia. What we can't have here is we're extracting X litres of high strength ammonia per day. Yet actually we're very close to our nearest receptors, and that results in odour contacts. So again, that's really been front of mind as well in terms of making sure what we're doing within this little containerised unit isn't going to impact on our odour position.
Yeah, no, that makes sense. So one of the key takeaways for you, I guess, was sort of communications and engagement piece with operations, just so that they know what's coming next.
Yeah, I think if you're going to do any sort of project like this, where you want to implement something new or change a process, I think that is a key thing, because you get insights from the guys that operate these plants that you won't get from a framework partner design house. They just don't exist because they're not doing the job on a day-to-day basis.
Yeah, no, absolutely. Okay, perfect. Well, if nobody has anything else to add, I think we are out of questions now, so it's time to wrap up the session. So thank you all again for the hard work you put into today's session. I think it's been a really great informative session, lots of really good questions. So thank you to the audience as well for the really great questions and for staying engaged throughout. So my colleague Kira will shortly pop a poll into the chat. I think it's already in there actually. So if everybody could just take a moment to answer the poll, it really lets us know your feedback, which we find really valuable for our future events. So please do take a moment to let me know. If you have any more specific feedback as well, you can always email myself. And I'm sure the team are happy to answer any further questions you have for them as well. So their contact details will be in the case study as well for you. So as we say, within a week from today, roughly, we'll be looking to upload the written case study along with the recording of today's event and any questions that we didn't get around to answering. So keep an eye on our platform for that and keep an eye on LinkedIn, as we always let you know on LinkedIn when we do post the case study. Okay, perfect. Well, thanks again everyone for coming, and thanks again to the team, and hope everybody has a lovely day.
Thanks.
Thanks, everyone.